Hello and welcome to our next video in class problems chapter 14. I believe this is video number 3. So here we got number 14 and 15 left, so let's get into 14 first and then I'll talk about 15. So we have a research team who's interested in the various negative health outcomes associated with smoking in adolescents. Suppose the team wants to determine if there's a relationship between cigarette smoking and height under the hypothesis adolescents that smoke more will be shorter. In order to test their hypothesis, the researchers conducted a simple random sample of adolescents that meet their criteria. The following table represents the information for each participant. So here we have our X value, and our y-axis is height, and our cigarettes is cigarettes smoked is our X. So part A wants us to create a scatter plot that graphically displays the relationship between cigarettes smoking and height in the SRS. So just a quick one. So we'll have label our axes X, Y, and it'd be something, you have your data tick points here. However many spaces you want them to be, and you'll have your tick points here. And when you graph it, it will look something similar to this in its shortest form. And when you look at this in its short, you see that you have a kind of negative slope here. So we would say that there's going to be, for part B, describe the relationship based on the observation, that you would see some sort of negative association, right? We can't tell the strength of it, right? It looks like it could be close to a -1, but we don't know for sure, and we can't tell with our eyes. We'd have to do an R statistic in order to determine that. So the best course is always to say there's a negative association there. We're not sure on the strength, but I would say it's probably going to be a strong one. Part C then has us calculate descriptive statistics and the correlation coefficient representing the relationship between the two variables. So once again, we have our X and Y. So when we need to calculate descriptive statistics, we need to find our X bar and our standard deviation of X, along with our Y bar and our standard deviation of Y. Once we have those, we can then get our ZX and ZY value, and then we can plug and get in our R. So to give you your summary statistics here, your X bar is going to equal 12.6. Your standard deviation should be 4.615. Y bar is 63.6, and your Y standard deviation should be 2.07. When you plug all this in and you get your ZX, ZY, you'll get an R value. Your R value should equal -0.831. Once we have our R value here, let me fix that one real quick. -0.831, that is our R value. So we would say, yeah, there is, it's a strong negative association, right? We can tell it's strong because it has absolute value of R being greater than 0.7. So we have a strong, we know it's a negative association based off the negative value and the fact that it slopes from the y-axis down to the x-axis. That's how we describe our relationship. Part D wants us to construct a regression line for the relationship and interpret your slope. So remember, our regression line is y hat is going to equal a plus bx. Covered this in the last problem here, so I'm just going to scroll up. When you do your B, it's R times the standard deviation of Y over standard deviation of X, and A is your Y bar minus B times X bar. So the same rules apply here, and when you do that, you're going to get an A value. Sorry, it's not capital. Excuse me on that. A is going to equal 68.303, and your B will equal a -0.373. So when you construct a regression line, it'll be your y hat is equal to 68.303 plus a -0.373x. And then how do we describe it? So it doesn't ask us to describe it, or it does ask us to interpret our slope. So when we interpret our slope, we were going to say that for every 1 unit change in height, there is a -0.373 unit change in, I'm just going to abbreviate it, cigarettes smoked. And that's how we interpret it. Okay, and so that completes the packet, except for number 15. And number 15 is a this problem is a little more challenging of a problem, right? We're getting into a lot more of the regression, and this is just kind of a to make the well-roundedness of this chapter come out. But chapter number 15 won't be on the exam. It won't show up because we're not doing that much more in regression. The other part of regression I really want you to know is to understand the formula and what it represents and how to calculate A and B. But if you want to go a little bit further and give yourself a little bit of a challenge, number 15 is here. So we're going to talk about number 15 here, and here we have researchers are interested between years of education and the income you earn. So here's your table in years and income. Notice how it doesn't tell you what your X and Y are. You would have to figure this out. Like I said, this one's a little bit more challenging. But what I am giving you is the computer output that summarizes. So if you did an SPSS output, or you can even do it in Excel, it's a little, the table looks a little different, but gives you the same information. You'll get this table here. And this table gives you your B, and then your standard error and your beta. The table left your t-value blank because you're calculating your t-statistic in part C, and it left the significance level blank because that's what you're calculating in part D here. But first I want you to construct a regression equation for the relationship of the two variables. So our equation is always going to be our y hat equals a plus bx. For this particular one, to help you out, your y hat is also equal to your annual income. So that is your y variable. So your annual income is going to equal to a negative 43711.113 plus, that's your a value, plus your 7,219.286 x, and there's your b. So your equation would be this, and your x being, of course, education. So when we write out a null hypothesis, remember we write out a null hypothesis and we're dealing with linear regression, our null hypothesis is going to state that beta is going to equal 0, and our null hypothesis, or that's our null hypothesis. Our alternative hypothesis is going to state that beta is not equal to 0. Then you calculate your test statistic. Your test statistic, since you have two variables you're looking at, is going to be a t-test, and your t-test for this is going to be your b over the standard error of b, where your standard error of b is equal to sy of divided by x divided by the square root of the sum of x minus x bar squared. If you're wondering what SXY is, SXY equation is equal to 1 over n minus 2, the square root of n, 1 over n minus 2, times the sum of the residual effect, or the residual outcomes you have from your line squared. Now, you can calculate all this by hand, of course, but this is where we have computers, and computers are amazing to help us with solving this stuff. And as you can see, it tells us what our standard error is up here. So the standard error of B is given to us right there, and we know our B value is here. So this chart tells us what we need, but these are the formulas and how they actually calculate them. So when you want B over standard error of B, you're going to just take your 7,219.286 divided by 936.012, and that's going to give you a 7.713 t-stat. Always recommend knowing what you're solving for. There's your t-stat. Oh. And of course it's like locked up on me. There we go. There we go. All right, sorry about that, back into it. And then, so we have our t-stat. So in order to look at our t-stat, we go to our table C in the back of the book. And if we want to interpret an alpha level 0.05, which is what it's stated up here in the beginning, at an alpha level 0.05, and we're doing a two-tailed test. So we're looking at alpha level 0.05 two-tailed test. We find that our t-crit value is 2.447. We see that our t-stat is 7.713, and so it is higher, so it is significant at alpha level 0.05. If you look down even further, it's significant at at a p-value of 0.001. Okay, so we would say it is significant at alpha 0.05 with a t-stat of 7.713. All right, so number 15 is a little bit more understanding the table and putting it out, but totally doable with the model here, and totally doable by hand too. Just it would take a little longer, and that's going to conclude